Okay, so I've talked about the common radicals that can combine with some of these metals to form compounds. Okay, now let's look at some of the questions. Okay, so let's look at some of the questions here. So these are the questions here. Okay, so we are starting with those that have chemical formulas, and then we name them, and then we are going to where we have the name, and then we want to find out the chemical formula. Okay, so let's begin. Okay, so they're saying name each of the following compounds. Okay, so the first one there is BaSO3. Okay, BaSO3. Okay, so this guy here, let me write it on the other board. So BaSO3. Okay, so to name this guy, you just have to know the name of the metal and the name of the radical. Remember, right now we are dealing now with radicals, right? So this is a radical, okay? So I said, this radical, what do we call it? Okay, I'm sure I listed it out. Okay, I said that was the sulfide because there's the 3 there, right? Okay, so if we break this formula into ions, it will be Ba2 plus and then plus SO3 2 minus. Okay, you see that the 2 minus and the 2 plus will cancel out to make this compound have a 0 charge, right? Okay, so now how do you name this? You just have to know the name of this metal. This is barium, and then the name of this radical is what? Sulfide. Okay, so it means the name of this guy will just be barium sulfide. Okay, so the name will be barium sulfide like that. As simple as that. So you just have to know the name of these radicals. If you don't know the name, then you can't name them. Okay, you can't name them. So you have to memorize them. I'm saying the list later on in the group. Okay, let's look at the other one. So if you have a question, just unmute yourself, you ask. So the other one now that we have is this one. We have K, M, N, and then O4. Okay, so what we can do here is separate this guy into its ions. Okay, so I can see a potassium and I can see a permanganate. You can see a permanganate there. Okay, so if I break them down into ions, I have positive ions for the potassium plus negative ions for the permanganate, like that. Okay, so you see that this -1 and this -1 cancel out to make this have charge over 0. Okay, so what is the name of this guy? We're just going to say the name of the metal, which is potassium. Okay, and then at the end, we are writing the name of this radical here, this guy here. So that guy is just permanganate. Okay, so the name of that chemical compound is just potassium what? Permanganate. Okay, so that's potassium permanganate. All right, and then we look at the third one, which was, I've forgotten it. It was what? So we have NaNO2. Okay, so Na is a metal, and then NO2 comes from the radical. Okay, so this radical here is what I said as the nitrite. Okay, so if I break down this into its ions, it will be Na plus and then plus NO2 minus. So this is a nitrite. Okay, so the name of this compound will just be sodium. Okay, you get the name, you get the metal first, sodium, and then you write the name of the radical there, which is the nitrite. Nitrite. So there should be I. Okay, so here it should be nitrite like that, because here we have 2. Okay, so if I add something like NO3 minus, this is what we call as nitrate. Okay, so this here will be nitrate. So where there's I here, we just put Ka. But if there's 2 there, then it's called nitrite. Okay, so this chemical formula here is sodium nitrite. Okay, so that's how you can name that one. And then let's look at the other one here. So the other one was K2, and then Cr2, okay, O7. Okay, so this compound here, guys, is a very common compound in chemistry. Okay, the potassium permanganate and the potassium dichromate, they have similar properties, and then you are going to encounter them a lot, especially when you reach the balancing, okay, in acidic media, in organic, basic media, acidic media. You are going to be dealing with these compounds, okay? So this compound is made up of potassium. So that potassium there, okay, it has a +1 charge. Okay, so if I'm breaking this into ions and I have a 2 in front of this potassium as a subscript, this 2 comes in front here. And then I say potassium plus, and then I'm going to say plus, and then this C2O7, it has a charge of -2. Okay? So this -2 charge plus 2 positive charges from the potassium, they make this guy here to be 0 charged overall. Okay, so how do we name this? We just get the name of the metal and combine it with the name of the radical. Okay, so this will be potassium. Okay, this would be potassium dichromate. Okay, so these ones, these names here, you just have to master them. There are not two ways about it. Okay, so this radical here is called a dichromate. Okay, so you have to know it by your heart that when you see something like this, it's just a dichromate. Okay, all right, so that will be the name of this guy here. So any questions there? For now, we are coming up with these names. Don't feel shy, guys. Come on, we want to learn. Okay, so if you don't understand, ask.
Okay, my question was, how are you able to tell, for example, when this compound that dichromate, how are you able to tell it has a 2- charge?
Okay, so I think before we started this, I was giving some of the common radicals that we use. So I think I gave it. Where is it? So this one here, you've seen the dichromate. I think I gave it here. So in its natural form, as a radical, it exists in this form like this, okay? So when you see it in a compound, okay, it means it just combined with a certain element, okay, but it's still dichromate. So whenever you see Cr2O7 in a compound, just know that that part of that compound came from the dichromate. Okay? So you have to know these special radicals. Okay. I managed to list down some of the few ones, okay, but there are a lot. But these ones that I listed here are the common ones. So we have the permanganate, you have the sulfate here, all these that are listed here. Okay, so you have to know them.
Okay, yes, I've seen how you have listed them. Now my question is, like, for example, for permanganate, how are you able to tell, say, as a -1 charge, like you have indicated at the end? How are you able to tell?
Okay, I'm not able to tell. It's just like that's how it is. It has a -1 charge. That's how it's given in chemistry. Okay, it's like what can I say? Like your name. Okay, it's like your name. So if your name is Paul, okay, if your name is Paul, then you'll be able to tell that, let's say you are a boy, okay, if your name is Paul. It's rare to find a girl who is named Paul, okay? So this compound here, I'm not able to tell, but that's how they are given, okay, according to the chemistry standard, okay? Whenever you see a permanganate, just know that it has a -1 charge, okay? So I'm not able to tell. I'm just getting whatever is there, and then I'm using it here. Okay, so you never find a permanganate that has another charge as long as it's a permanganate, it will have a -1 charge. So that's why I was saying you have to master these because they are given and you just have to know them like that. Okay, they are special radicals. And like if it's a single element, then we can tell how we're able to tell that it has a certain charge because we'll go on the periodic table, check the group where it is. Then depending on the group where it is, we'll be able to tell the charge that it has. But these ones here are special radicals. So meaning their charges were found after a series of experiments were conducted. Okay, so after those experiments, then they gave them those charges. So you just have to know them like that. Okay, so manganate is always -1 and all these that are listed here. Okay, so we are not able to tell, but they're just given like that. Okay, and then, okay, so this was the last question that we were, and we're able to tell that its name is this one here, because I can see a CR207 here. Okay, so it means this guy here came from a dichromate. Okay, and then the other part now, we'll be getting the, oh, someone has a question?
And one more last question. Like, Kylie, there are a lot of elements in the periodic table. So
Yes.
my question was, there's no way whereby you can use the periodic table to say this is the specific charge, like for permanganate, this is the specific charge it has, which is -1. And then just like that, whereby this rather than equal system memorizing, so what's the factor? Yeah, got -2, -1. Like that, who are the periodic table to find out the specific charge?
Okay, no, you can't use the periodic table to find, okay? So these are special radicals. The charges were found by experiment. So you can't use the periodic table to find their charges. Okay, but if it's a single element, then you can use the periodic table. Okay, have you gotten that? Because if we say we 5, maybe this is the potassium permanganate, right? And then we are saying it has a -1. So if you get the charge of this guy here, the oxygen, it will be 4 multiplied by -2 from the periodic table, right? And then this is manganese. So where's, what is the charge of manganese? Okay, what is the charge of manganese from the periodic table? Let me check. So manganese is where? Okay. Huh? I can't see it.
Yeah, just here, Pama transition methods.
Okay, so this is the what?
Manganese, yes.
Okay, so manganese has what charge? Okay, so you discover that manganese is a transitional metal. Okay, so transitional metals have different charges depending on what they are combining with. Okay, so it doesn't have one charge. So we can't get a specific charge and then use it in that formula. Okay, so it can be +2, it can be +3, or is it +6? Okay, so if we get any of those and then we try to, where is it? We try to combine with this 8 that we have here, we won't get this -1, okay? Because manganese is a transitional metal, okay? So we just have to know that the potassium permanganate, okay, it has a -1 charge like that. Okay, and then let's look at...
what about, let's say, for example, there's boron there. How do you tell the charge for boron? Isn't it predictable? Since it's a boron. I was asking if we can go back to the periodic table.
Okay, where is the periodic table here? Boron, this one here. Okay, boron has a charge of 3.
So that's -3 or +3.
Okay, it's +3 for boron.
So now how do you tell if it's positive or negative?
Okay, I thought I explained. I said the first 3 groups, okay, we have metals. So the charge will be positive because they are losing those electrons to attain stability. And then I said the next 4, they are non-metals, they are groups for non-metals, okay? So you are going to have a minus charge.
Okay.
Yes, so the first
So
3
even
groups here,
this
this one, and this one, they are metals, and then these are non-metals.
then the noble gases is just neutral.
Yes, the noble
This
gases,
is
these
the
ones
A.
here. These ones here have a 0 charge.
Okay, so zero charge. Okay, thank you.
All right. Okay, so now let's look at the last part of these questions here. Okay, so the last part of the questions, we have a name, and then we want to find its formula. Okay, we want to find its formula. All right, so some of these formulas here, they contain the transitional methods, like the first one here and the second one there. Okay, so the transitional methods always move with the values that they are using in that chemical formula. Okay, so you can see here they're saying chromium 3. It means that this chromium here is using a valence of 3. Okay, or when they say lead 4, okay, because this is 4, lead 4, it means that this lead is using the valence of 4 in that compound. Okay, because the transition metals always have more than one valence. Okay, so they always carry the valence that they are using in their name. So this is chromium 3 hydroxide. So how do we write the chemical formula for this? Okay, so the first thing always is to identify what we have. Okay, we have this chromium, which is given by Cr. Okay, and then we have this hydroxide. Okay, so this hydroxide here, okay, it has a -1 charge. We know that hydroxide has a -1 charge. Why? Okay, because it's a special what? Radical. Or you can say it's water that has lost one of the hydrogens. Okay, so this hydroxide, okay, remember when I was giving those common radicals, I said it has a valence of what? 1. And then this chromium here, because this chromium is a transition metal, its valence is always given in the question. So chromium 3, it means the valence that they are using here is what? 3. Okay, and then this chromium, if it's using a valence of 3, it means even the charge there should be 3. Okay, so when you combine these 2 elements here, I mean this element and this radical, what are we going to get? We are just going to do that cross multiply, like, okay, so it means the one will go with the chromium like this, and then the OH, okay, you put it in brackets like that, it will go with these 3. So why? In order for this overall charge for this compound to be what? To be 0, okay? So this chromium here has a +3 because it's using a valence of 3. And then this hydroxide, it has a charge of -1. So what do we do in order to balance those charges? Okay, we put 3 of the hydroxides. No wonder we are seeing these 3 here. Okay, so this chromium 3 hydroxide, its chemical symbol will just be this guy that I've written here. Okay, and then it will be the same thing for this lead 4 carbonate. Okay, so we first have to write the lead here. So lead is given by Pb. So since it's lead 4, it means the valence that it's using is what? 4. And then this carbonate here, okay, what's the chemical symbol for a carbonate? We said it was this 3, and then -2 like that. Okay, so this is a carbonate, okay? So since it has a charge of -2 there, okay, or a charge of 2-, it means its valence is what? Is 2. So we are combining a lead with a valence of 4 to a carbonate, okay, with a valence of what? 2. So we're just going to draw that across multiplication. So it means this 2 goes to the lead. So we have Pb2, and then we have this guy here with a 4. So CO3, and then a 4 outside. Okay, so these 4 and 2 have something in common. A 2 can go both in 2 and in the 4 there. Okay, so we are going to divide 2. Okay, so we divide this guy by 2, we divide this 4 by 2. We are going to have PB with a 1 here, but we won't write the 1. And then we have CO3, and then we have a 2 outside after dividing this 4 by the 2, right? Okay, so this formula here is the chemical formula for what? For lead 2 carbonate. Okay, so I don't know if there are any questions there, guys. Okay, no question. Let's look at magnesium cyanide. Okay, so cyanide, I gave you the formula, you guys, and I even gave you the charge of this compound here. Okay, so let me write it here. So we have magnesium cyanide. Okay, so magnesium, it has the symbol Mg, okay? And then this cyanide here, it has the symbol Cn. So what did I say was the charge of cyanide, if anyone remembers? What was the charge of cyanide?
You said the charge for cyanide is -1.
Exactly. Okay, so the charge of this guy is -1. So meaning the valence of this whole radical here is just 1. And then we know that the valence of magnesium is 2. So we're just going to do like a cross multiplication like that. Okay, so it means the Mg gets the 1, but I won't write the 1. And then this Sn like that gets the 2. So this one here is the chemical formula for magnesium cyanide. Okay, so it's very important for you to know those radicals, guys, especially the common radicals, like the permanganate, the dichromate, the sulfate, the carbonate. You have to know them. Okay. All right, and then the last one for today was ammonium. Okay, so we had ammonium acetate. Okay, so I think I didn't give the charge for the acetate, and I also didn't give its formula. Okay, so ammonium, okay, ammonium and acetate are both radicals. Okay, so in this chemical formula here, we don't have a metal. Okay, we have ammonium, which is a radical, and we have acetate, which is a radical. So this ammonium radical, okay, is one of the rarest radical that you can find, because most of the radicals that we have are negatively charged. Okay, but ammonium, okay, it is one of the rare radicals that you can find because it's what? Positively charged. So we have ammonium radical, which is given by this. It is NH4, and then it has a plus charge like that. So this is the ammonium radical. And then this acetate radical, okay, it's given by C2, and then we have H3, and then we have O2, and then a minus charge like that. Okay, so this one here is what we call as the acetate radical. And then this one here is the ammonium radical, one of the rarest radicals that you can find because it has a positive charge. Most of the radicals are negative. Okay, so now, since this one has a positive charge, it means it has a valence of 1. Even this one, since it has a -1, it means the valence is 1. So when you do that cross multiplication, it means we are going to have NH4, okay, and then C2H302. So this one here is the chemical formula for ammonium what? Acetate. Okay. So any questions there? I think this was our last question for today. Any questions there? Okay, so
On ammonium, there's a 4 there for the charge, and then there's for acetate, there's a 2 there, and oxygen 3 2. So you can't divide it whereby it remains NH CH3 in O plus for oxygen. You can divide it like that.
No, you can't divide, okay? So when you notice, okay, so if you look at this here, the 4 is just on the H there, okay? And then when you look at this other one here, the 2 is just on the O there, okay? So unless you have a number that is on everything here, let's say maybe I had these in brackets, and then I have a 2, and then I have these in brackets, and then I have a 4. So here now you can divide. But the way they are, no, you can't divide, okay? Because this 4 is just on the H, and that 2 is just on the oxygen there. So you can't divide.
Yeah, and I have a question I wanted to ask. Is it necessary to indicate the state symbols?
The state symbols when you're naming the compounds?
Yes.
No. When you're naming, no. But when you start doing the reactions, then you always have to indicate the state symbols. But when you're naming, no, they're not important.
All right, thank you.
Yes. Okay, guys, so that's that. Thank you for coming through. Okay, I'll share the lessons with you when I upload them. For those who want to rewatch whatever we did, okay, and so we'll continue the classes tomorrow, same time, 21. Okay, so have a blessed night.